Hi everyone, welcome to this video where we will discuss about a few best practices for security, identity and compliance on AWS. Before we begin with the content for today, let me give a little introduction about myself. My name is Aishwarya Sood and I am working as a lead coach in the AWS domain, and I am 3x AWS certified, Amazon authorized instructor, also an AWS Academy accredited educator. You can connect with me on LinkedIn on the given link. This profile name is given here, and also you can scan this QR code to directly view my profile. So in today's video, what we are going to discuss, we will start with the very basic principle, the least privilege principle for the better security, IAM policies and the foundational best practices standard available in the security hub of AWS, and then AWS guard duty, few things about encryption, and then about governance and the incident response. So this is all that we will be discussing in today's video. So let's get started with the first topic for today. As we are going to discuss about security best practices today, first let me tell you about what credentials to be used for your daily usage on AWS as per the best practices. It is recommended that you do not use the root user for your everyday tasks, even the administrative ones. Instead, use your root user credentials only to create your IAM admin user. Then securely lock away the root user credentials and use them to perform only a few account and service management tasks. For everyday tasks, for even more security, you can prefer using IAM rules to delegate permissions over using an IAM admin user as well. Okay, so basically IAM admin user also has all the permissions to all the services. Root account also has it, but there are still a few actions, the account level actions, which can be done with the help of root account only. But anyway, for frequent usage, it is not recommended. So keep the root account credentials secure. Before we get started with the discussion of best practices, I hope you all understand the importance of security. In fact, security is a job zero at AWS, which depicts that it's even more important than any number one priority. So today we will discuss a few best practices for security, identity and compliance. First and foremost, we have a very basic and important thing, the principle of least privilege. Least privilege is a principle of granting fine-grained permissions, means only the permissions that are required to perform a task. And least privilege is also one of the many AWS well-architected best practices that can help you build securely in the cloud. So for example, a small example for this least privilege principle, if you have an EC2 instance that needs to access an S3 bucket to get the configuration data, you should only allow read access to the specific S3 bucket that contains the relevant data, and an entry pattern will be to allow this EC2 full read and write access for this S3 bucket. That is not needed, although that can also satisfy the requirement. But according to the best practice, according to the principle of least privilege, you should give this EC2 the permission only that is required to perform the specific action. That leads towards the principle of least privilege. So in this video, we will take few examples of IAM policies that attach to the IAM principles following the principle of least privilege. How it works basically is we just go to the identity and access management, and while giving the permissions, we have to apply the principle of least privilege. There we define who can access or not, and if yes, then what they can access. Okay, through the policies and permissions only we will be defining. So we have to define who can access, which user, which principal, what they can access if so, okay, and who can access or not, and what they can access. So this is what we do. So main policies of a policy document, what all they include. These are the main elements which we will be discussing now, so that you can understand what all sections you need to add in your policy to apply the principle of least privilege. First thing will be effect. It specifies whether the statement will allow or deny an action. Then we will be having action, which describes a specific action or actions that will either be allowed or denied. For example, S3 create bucket is an S3 service API action, and IAM action that enables an IAM principal to create an S3 bucket. Then not action. It can be used as an alternative to using action. This element will allow an IAM principal to invoke all the API actions to a specific AWS service except those actions specified in the list. Okay, and then we have resource. It specifies the resources, for example an S3 bucket or objects that the policy applies to in the ARN format, that is the Amazon resource name format. So we have to specify the ARN of the resource. Then not resource. It can be used instead of the resource element to explicitly match every AWS resource except those specified. So not resource, you can think of that as other than that. Okay, so not resource, you will specify that like other than the resources that are specified here, it will be applicable or not applicable to those or not. Okay, then there is condition. It allows you to build the expressions to match the condition keys and the values in the policy against those keys and the values in the request context that is sent by the IAM principal. So this condition can be service specific or global as well. Global condition key can be used with any service. For example, the key of AWS current time can be used to allow the access based on the date and time. So now we will have a quick look at how to configure a small policy that follows the principle of least privilege. We will see a policy. Let's say you have a Lambda function which needs a permission to get specific objects from Amazon S3. So what you can do, you can grant him the full permissions, you can grant whatsoever permissions that are there as a managed policies, but that would not be the principle of least privilege. So for following the principle of least privilege, we have to give the specific permissions for our Lambda function. So we will create a policy accordingly that can be used with such a function. So let me log into my AWS console and we can get started with this. So we have to go to IAM and we will create a policy there. I will go to the policies to create a policy and let's click on create policy. So first of all, what we have to do is to choose a service, and we can select only one service at a time, and right now in this demo we just need one service, so not an issue. I'll go ahead and search for S3. Here it is. Now once the service is selected, it is showing me the access levels that are available. I can say all S3 actions S3:*, but no, that's not needed because we are demonstrating the principle of least privilege. So we will click on read what all things are there available, because we want to give our Lambda the permission of getting the object. Okay, so I'll expand this. I don't want to give all the actions. So what we can do is we can just give the get object. Yeah, that will be enough for our Lambda to get some objects from our S3 bucket that we will be specifying. You can see we could have given all the read access, we could have given all the list access, everything we could have given, but we are just giving the get object. So you can click on this question mark to know further details about it. Then specify the resources on which it should be applicable. Should it be all the resources? Should it be specific? Since we are following the principle of least privilege, that means we have to choose a specific resource. Okay, so we will click on add ARN and we will say bucket name we will be adding here. So let me copy a bucket name from here that we can use. I'll use this bucket name that I created for a sample. And then object name, we will add a prefix for our object name as well. So right now I just have one object here, so what I'll do, I'll say any object that starts with sample file will be allowed. So I can give a star here, sample file star. So any object that has a prefix of this will be allowed. So this is the principle of least privilege, that I am allowing the Lambda specific permissions to a specific S3 bucket whose name is this, and in that also only the objects whose name starts with the sample file, only that object I am giving. So I will say add. Apart from this, the last step will be to add a condition that you can add, okay, that MFA is required or the source IP should be this, only then the request should be applicable, the permission should be applicable. Multiple conditions you can specify, you can add more conditions as well. Okay, let's say if we say source IP should be this only, so I can specify one IP address that, okay, let me enter a sample IP address that if I say this IP address, that means if the request is coming from this IP address, only then this permission will be applicable, otherwise not. So right now I won't be adding the condition as such, okay. So you can add more conditions as and when whatsoever you need it. Right now we will just go ahead and proceed towards a further step. So we can add a tag to our policy, okay, let's say name S3 for lambda, let me say, and then I will review what I have added as a permission. I will say policy for S3 policy for lambda, okay. So you can add a description for this policy, what it is doing, and then if you are okay, then you can click on create policy. So now the policy has been created. What you will have to do is just give this policy to your lambda, or you can create a role, attach this policy to that role, or anything that you want. So this is a very simple process. Only the thing is that you have to assign the permissions accordingly so that it is sticking to the principle of least privilege. Now due to the time constraints, I won't be able to create a lambda and attach the policy to this and show you the effect, because we have to see a few other demos as well. But you can try this out. You can create a lambda function, you can attach this policy to it, and you can try accessing different things in S3 and see what it is allowed to access and what not. So for now, let's go back to the slides and start with the next topic for today's video. So another thing that can be used in the context of best practices for security is the AWS Foundational Best Practices Standard that's available in AWS Security Hub. This Security Hub is a cloud security posture management service that performs the security best practice checks, aggregates the alerts, and enables automated remediation as well. So this AWS Security Hub has launched a new security standard called AWS Foundational Security Best Practices. This standard will implement security controls that detect when your AWS accounts and deployed resources do not align with the security best practices which are defined by the AWS security experts. So we can quickly assess our high priority security alerts and security postures across AWS accounts in one comprehensive view, as it aggregates the findings from various resources and accounts. By enabling this standard, you can monitor your own security posture to ensure that you are using AWS security best practice, and this standard is enabled by default when you enable the security hub in a new account. So no extra steps are necessary to enable it. But if you are an existing security hub user, when you open the security hub console, you will see a pop-up message recommending that you should enable this standard. So we will have a look at like what is this standard and what are all the findings that it has got. Our goals will be first we will be enabling the foundational security best practices standard from the security hub console, and then we will see an overview of the security controls that are there, look into the security control details that we have got, and how to find the remediation instructions for a failed control. We will see the failed controls as well, the past as well, and the remedies for the failed ones, and how to enable a specific security control from there itself. So these will be our goals for the demo that we will be seeing now. So let's get started from the AWS console. So before we do this demo, we have to enable the config. You just have to click on config, okay, say get started, click do the one click setup, and it will be done. So I have already configured this AWS config. What I will do now is go to the security hub, okay, so that we can proceed our demo further. So you just have to click on one click setup and just confirm all these things. You can add anything that you want, but I'll be just doing the one click setup. So I say confirm and the config will be enabled. And you can see once it is enabled, it looks something like this. Okay, so any data, if that will be there, it will be displayed here. Right now I don't have anything much here, so it is showing like this. We will go back to the security hub console. We will say go to security hub, and let me refresh because I have already enabled this config. So I have waited for quite some time, and in my console the config is also enabled, but it is due to some reason it is not able to detect that the enabling of the AWS config. So if we go ahead with this kind of thing, it might show some issues later on in detecting the multiple things that it will do, because it will find no data from the resources that are there, because in config from my side I have enabled the recordings, but it is not able to detect that yet, so it might not be able to collect that data. Yeah, so you can see it is saying that no data is available. So due to those reasons we will not be able to finish this demo end to end. So what I'll do, I'll provide the link for another demo video that you can check it out, because here I am getting some errors, so we might have to try that later on. But anyway, we will go back to our slides. I hope you have understood a little bit about what we have discussed here. We will go ahead with our next demo, and this security standards demo you can refer to the another AWS video that I'll be giving in the description of the same video. So here we get to the guard duty. So this another amazing service that we have got from AWS in security is Amazon Guard Duty, which is an automated threat detection service that continuously monitors for suspicious activity and any unauthorized behavior to protect your AWS accounts, workloads and data that is stored in Amazon S3. So here we will discuss the enhanced, highly customized machine learning model of Guard Duty to better protect your AWS environment for the potential threats. So that is another model for which will be proving very useful for different use cases, because this model works at scale and across a broad spectrum of customer use cases, workloads and operating models. And you can also use an anomaly detection to generate the security relevant results, because this model operates on the continuous stream of the API invocations that will occur in the AWS account of yours, and based on a user activity that is tracked in the AWS CloudTrail. So this model is based on variational autoencoders, which have recently emerged as one of the most successful approaches to model the complex data distributions. That also is, this specific thing is based on that itself. And this allows this guard duty to learn the probability distribution of API calls invoked by users in your AWS account. Even if a user in your account operates in a certain way for the first time, the model will predict whether it is a part of their normal expected operations or not. It's this added probabilistic nature that helps to produce accurate detections of suspicious behavior within your account. So the suspicious behavior, that machine learning model about which we learned just now, can help you to detect many things, and few of them include unusual Amazon S3 discovery calls, and along with the various levels of access permissions, modifications, also the unauthorized creation of new IAM users, roles or the access keys to persist the access, and resource hijacking of Amazon EC2 instances for use in the cryptocurrency mining, and also generating Amazon RDS snapshots as a part of the extra filtration attempts. So these are some of the things, the suspicious behavior that the ML model of our guard duty can detect. So what we will do, we will have a quick look at sample findings of the guard duty that it generates, so that we can get familiar with the guard duty functionalities, so that before getting actually started for the real findings from our workloads, we can have the familiarity with this. So we will just have to go to the guard duty, and the very first step before we start using is this: we have to enable the guard duty in our account. So let's enable this. And as you can see, there are no findings as of now. So what exactly is a finding is like when guard duty discovers a security issue, it will generate a finding. So finding is basically a data set that contains the details that are relating to that unique security issue that has happened. So findings detail can be used to help you investigate the issue. Okay, this has happened, that has happened, and then you can think about the remedy for the same thing. So we will generate a sample findings just as of now for the demo purposes. For that we can go to the settings, and here you will see the option sample findings. So you can generate the sample findings from here, and there you can click on findings and it will show you all the findings. These are the sample findings, not the actual ones from my account, but just the sample findings. So you can see these sample findings have a different icon in front of them. So this red one means if you hover over there, it says it is for high severity, and it has the yellow ones has a medium severity, and this blue ones have a low severity. So if you want to get more details about this finding, that what exactly is this and what it is saying, we can just click on any of the finding that's available. Let's say I am clicking on the second one, which is unauthorized access. So how I can check it? I can click on this finding ID. It will show me a complete JSON file of the finding about all the details that are there, a very comprehensive detail about this finding. I can even download this JSON file from here itself, and then apart from this, in the resources affected section, I can see what exactly the resource in my account has been affected. So because this is just a simple finding, but in a real finding, this information here will help you to identify a resource in your account that should be investigated, and will include the links to the appropriate AWS console for actionable resources as well. Okay, let's say some particular EC2 instance is there or something is there. It will tell, okay, this is a resource that is affected, so that you can click on that particular instance ID or something. It will take you to that specific EC2 so that you can investigate and see what has happened. Any resource it can be there. So this is how I can investigate my findings. Let me select anything else, like it is showing high severity. Here you can check out the JSON format details of all the details of the finding, and resources affected, you will be getting all the details over here. After you are done reviewing the sample findings and now you are ready for generating the real-time findings, what you can do is you can just select all of these and you can archive them. Okay, so you can archive so that they can be hidden. These all findings, the sample findings will be hidden, and you can deselect any of the finding that you want to keep and not archive. Apart from archiving, apart from hiding, you can even export these findings to Amazon S3. Because in guard duty, the storage limit for the findings is 90 days. But if you want to store it like indefinitely for a longer time, you can export all these findings to Amazon S3. So what you have to do for that is just go to this settings, and here you have findings export options. Okay, so you can say configure now, and it will take you through all the steps. You can say if export them to an existing bucket in your account, or to an existing bucket in some other account, or you want to create a new bucket. So you can say create a new bucket. You can give a bucket name here, and once you give the bucket name here, you will have to choose a KMS key as well for the encryption. You can choose an existing key, or you can choose to create a new key as well. Once that is done, just save it, and within 5 minutes your findings that are there, it will start getting exported to the Amazon S3. You can just confirm from there on. Apart from this, we have one more thing that we can connect it to an SNS topic for the notifications. So this can be done with the help of using Amazon SNS plus Event Bridge, because what happens is this guard duty will integrate with Amazon Event Bridge, which will be used to send the findings data that it has collected to other applications and services for processing, which will be acting as a subscriber in the SNS topic. So with Event Bridge, you can use this guard duty findings to trigger the automatic responses to the findings by connecting these finding events to targets such as Lambda functions, EC2, systems manager automation, and the SNS service, and many more than that. Okay, so that anything that has been found here, it will be detected in the event bridge. Event bridge will send a notification over to the SNS, and the SNS will send it to the subscribers of that, so that the process can be automated. All those things can be done there. So that was just a quick overview of guard duty. You can explore it more based on your use cases. Now let's discuss the security of a few other resources, the network resources. Now any workload that has some form of network connectivity, whether it's the internet or a private network, requires multiple layers of defense to help protect from external and internal network based threats. So best practices can be to create network layers where we can group the components that share the reachability requirements into layers. For example, a database cluster in a VPC with no need of internet access should be placed in the subnets with no route table, which contains the internet gateway entry. Okay, basically in a private subnet we can keep it. In a serverless workload operating without a VPC, similar layering and segmentation with the microservices can achieve the same goal that we are having here also. Then we have to apply the controls with the defense in depth approach for both the inbound and traffic, because we have to control the traffic at all the layers, not just one or two. For example, Amazon VPC includes the security groups, NACLs, and the subnets. For Lambda, we can consider running it in a private VPC with the VPC based security controls that are like security groups, NACLs again. Also automate the protection mechanisms to provide a self-defending network based on the threat intelligence and the anomaly detection. For example, the intrusion detection and the prevention tools that can proactively adapt to current threats and reduce their impact. Also inspect and filter your traffic at each layer. For example, you can use a web application firewall to help protect against the inadvertent access at the application network layer. For Lambda functions, third-party tools can add application layer firewalling to your runtime environment. And apart from this, compute resources, which are the core components in your workload, they also require multiple layers of defense to help protect from the external and internal threats. So these resources basically include EC2 instances, containers, Lambda functions, database services, and more. What we can do is we can frequently scan and patch for the vulnerabilities in our code, dependencies, and in our infrastructure to help protect against the new threats. Apart from this, we can reduce the attack surface by hardening the operating systems, minimizing the components, libraries, and externally consumable services that are in use. And then implement services that manage the resources such as Amazon RDAs, Lambda, and Amazon ECAs to reduce your security maintenance task as a part of the shared responsibility model, because for the managed services those things will be taken care by the AWS, and the security also, since they will take care, we can rely on that security. Then also automate your protective compute mechanisms, including vulnerability management, reduction in the attack surface, and management of resources. Also, removing the ability for interactive access reduces the risk of human error and also the potential for manual configuration or the management. Like for example, you can use a change management workflow to deploy EC2 instances using infrastructure as a code, and then manage the EC2 instances using tools instead of allowing direct access or a bastion host. So for this purpose, the CloudFormation and the systems manager can be taken into consideration. Also implement the mechanisms, for example, code signing, to validate that the software, code, and the libraries used in the workload are from trusted sources and have not been tampered with. Okay, so that's few basic points about the security for the network and the compute which you can take care of. Apart from this, we have a few data protection options on AWS, which basically leads towards the encryption. So you have these several options available for encrypting your data and managing the keys on the platform. It is just up to you that how much security you need and how you want to manage that. Based on this, you can decide an appropriate solution for your use case. First we have is AWS KMS, which provides customers with a centralized control of their encryption keys. Because when we do the encryption, you all know we need the encryption keys to be managed. Customers can easily create, import and rotate the keys as well as define the usage policies and audit that usage from the console, the AWS console or the SDK or the CLI. The master keys in KMS, whether imported by the customer or created on the customer's behalf by KMS, they are stored in a highly durable solution in an encrypted format to ensure that they are protected and can be retrieved when needed. Apart from this, another solution we have is Cloud HSM, or we can expand it as Cloud Hardware Security Model. So this enables the customers to easily generate and use their own encryption keys with AWS services. With the Cloud HSM, the customers can manage their own encryption keys, and it is a fully managed service that automates the time-consuming administrative tasks such as hardware provisioning, software patching, high availability and backups. So we can use Cloud HSM when we want ourselves to manage the hardware security modules that generate and store our encryption keys, because in key management service the tenancy will be a shared one and the hardware security module will not be under our control, but in Cloud HSM it will be. So in such cases, when we have the requirement, we can go for Cloud HSM. Apart from this, we have the AWS Marketplace Solutions, which offers a wide variety of third-party vendor solutions in the marketplace, which gives customers a choice to use a third-party key management solution that they may already be familiar with. And we can also bring our own or roll our own encryption solution with the like let's say the customers with the existing on-premises encryption solutions may be able to extend these solutions for use within the AWS, and that might be easy for them instead of going to a new encryption solution. So that was about encryption. Let's discuss a few things about the governance now. So when customers first move to the cloud, their instinct might be to build a cloud security governance model based on one or more regulatory frameworks that are relevant to their industry. Although this can be helpful for the first step, but it's also critically important that the organizations understand what the control objectives for their workloads should be. So governance is basically how an organization ensures the consistent application of the policies across all the teams. The best way to implement consistent governance is by codifying as much of the process as possible so that it can be standardized. And security governance in particular is used to support the business objectives by defining the policies and controls to manage the risks. And moving to the cloud provides you with an opportunity to deliver the features faster, react to the changing world in a more agile way, and return some decision making to the hands of the people closest to the businesses. And in this fast-paced environment, it's also important to have a way to maintain the consistency, scalability, and security. This is where a strong governance model will help for sure. And for getting started, AWS well-architected security best practices helps to build a strong and right governance model. So I understand creating the right governance model for your organization may seem like a complex task, but it doesn't have to be. You just need to understand it well and get started. So there are many customers who use a standard framework that's relevant to their industry to inform their decision making process. Some frameworks that are commonly used to develop a security governance model, and they include NSIT, Cyber Security Framework. You can see here the CSF. Then Information Security Registered SSS Program, that is IRAP, and the Payment Card Industry Data Security Standard, that is PCI DSS, or the ISO or IEC 27001, these standards. There are many more apart from the ones that are mentioned on the slide. Some of these standards provide requirements that are specific to a particular regulator or region, and others are more widely applicable. So you should choose the one that fits the need of your organization. While the frameworks are useful to set the context for a security program and give guidance on the governance model, you should not build either one only to check the boxes on a particular standard. It is critical that you should build for security first and then use the compliance standards as a way to demonstrate that okay, you are doing the right things. Okay, And apart from this, we will discuss a very small things about the incident response. So first of all, AWS says that security is the highest priority at AWS, as I told you in the beginning also. All the customers of AWS benefit from a data center and network architecture that is built to meet the requirements of the most security sensitive organizations. So the AWS cloud has a shared responsibility model, which I just spoke about it a few minutes back as well. But what it is, let me tell you. It categorizes the security responsibilities as security in the cloud and security of the cloud. So AWS manages security of the cloud, and customers are responsible for managing security in the cloud. This means that you retain the control of the security that you choose to implement, and you have the access to hundreds of tools and services to help you meet your security objectives. These capabilities will help you establish a security baseline that meets your objectives for your applications that are running in the cloud. Because when a deviation happens from your baseline, you may need to respond and investigate. Of course, you can't leave it that okay, some deviation has happened, some security issues has happened, I can ignore. No, you have to respond and investigate. To successfully do so, you must understand the basic concepts of security incident response within your AWS environment, and it is important to know which controls and capabilities you can use for resolving the potential concerns and to identify the remediation methods. So because security incident response can be a complex topic, it is recommended to start small, develop the runbooks and leverage the basic capabilities and create an initial library of the incident response mechanisms to iterate from and improve upon. For all these processes, we can follow a few things, like first, we can educate our security, operations and incident response staff about the cloud technologies and how the organization intends to use them. Also, we can prepare our incident response team to detect and respond to incidents in the cloud by enabling detective capabilities and by ensuring appropriate access to the necessary tools and the cloud services. Also, as a third step, we can simulate both expected and unexpected security events within our cloud environment to understand the effectiveness of your preparation. Okay, don't wait for the actual disaster to happen. Whatever you have implemented for this incident response, simulate that event, the expected event also, the unexpected event also, so that you can see that in that event how your mechanism is working. Do you need to make any changes into that? Is it all okay as expected it is working? So you can simulate those events and see the effects of your incident response mechanism, and then just iterate on the outcome of your simulation to increase the scale of your response posture, reduce the delays and further reduce the risk, because that will be understandable only when we see the effect of our incident response program. So to summarize this session, what we have learned today, the best practices for security, identity and compliance, which basically involve the identity and access management, the principle of least privilege that we have to follow, the good detection mechanisms, infrastructure protection in terms of network and compute, the data protection with the help of encryption, and then compliance, the frameworks, governance and the incident response. There are many more best practices for security, identity and compliance that are available, and many more services and features that AWS provides us for this, because this is a vast topic. In this video, we have covered just a few of them, and we can explore more about these best practices later on. So I hope you have understood the ones that we have discussed today, and we will now meet in the next video. Thank you.